Hello there, good evening to you, and this is Penjin video tutorial number 4. I just want to address something rather quickly, which was that Ubuntu released an update from 11.04, they're now on 11.10. This uses GNOME 3 instead of GNOME 2, which basically has upgraded the file manager there. I'm currently still running on 11.4, so I suggest you stay on 11.4 if you are doing these tutorials, just for consistency's sake. But in any case, if you have upgraded, there is an alternative SVN program I've found that you can install. I'll show you how to do that rather quickly. So if you go to applications there, if you go to your Synaptic Package Manager, search for it up in the search box if it doesn't appear in your most frequently used. Click that. Okay, type in the password Penjin. Okay, and in the search box here you can type ESVN. ESVN, there you go. I've already installed it, but you click that for install, hit apply, and that will be a nice alternative SVN program, just so you can keep the Penjin base code up to date, etc. But you will have to actually open that program. So to open that program, if you hit Alt F2, that's the Alt key, and then F2, it'll let you run a command. As you can see, I've got in my history ESVN. So if you type ESVN, it'll do the search for you and find that. So I'll click on this one here, and there you go. That opens the ESVN program. To use this, you just go File, Open Working Directory, and we want Document, Programming, Penjin, Penjin Base, and then hit OK. And as you can see, all up to date here, all on revision 288. And this is a simple SVN program. You can go modify update, and it'll run the update command, but it's already up to date. So there you go. That's that. The alternative way is if we go on to code.google.com/p/penjin/source/checkout. You can see it does give you the command line there. So it's svn checkout http://penjin.googlecode.com/svn/trunk, and instead of Penjin read only, you'd make that Penjin base. If you're not familiar with the command line, that might be a bit trickier for you, but that is there. So let's carry on with the tutorial then. Okay, so what we're going to do is we've got this example here, so we can open that up there. Open that with code blocks. Okay, and before we get started, I'm going to actually show you a couple of tweaks you can do, which will make things a little easier for you. So you want to go to Environment and View, and you want to make sure that Auto Show Hide Message Pane is clicked, because basically this pops up the useful window showing you any errors that happened when you get an error, so you can keep your editing space nice and large there, so you can see your code. And when you get an error, it will pop that up there. You can see the build log, debugger, build messages, etc. Incidentally, I'll also let you know that if you hit F2, you can pop that up and down as you need to. So that's something to bear in mind. But in any case, I digress, and we should carry on with our example. And what I was thinking is if we do a simple relatively simple Pong clone. So okay, we've got we got to a state title which showed a simple rectangle object. What we're going to do now is add another class there. So if we go to the example and we go, sorry, we don't do that, we hit the new file button, we do a new class. We call that class state main, because this will be the main game code for the Pong. You can call it what you want, state Pong if you want, but I'm going to go for state main. It does inherit another class, get my words out, inherits the base state. So we inherit that. Okay. In fact, the include will be Penjin states.h. Okay, header and implementation file shall be in the same folder. We need to change that so it is in our example folder, since that's where we've got all our current source code. And there you go, just hit create. New class has been created. Will you add it to the current project? Yes, we will. Okay. So we have a state main. Okay, we do have a state title, but we won't work on the title screen as yet. So, in order to actually run our state main instead of the state title, we will need to change the identifier here to state main. Okay. We'll also have to update the state management here. So we've handled the state title. We also need to add in an else if next equals state main state equals new state main. So that's that there. But I hear you shouting at the screen, but yeah, we haven't done anything with state main, and doesn't this need to know how to do it? Yeah, well, it does need to know how to do it, so that's what we need to do next. So we do have, in our headers section here, in example, we have user states. We need to include our state main in user states, and we also need to add the identifier, so add state main there. And also include state main in the list. Hash include state main dot h. Save all, and there you go. So that's updated the identifier. That's you know, we should be good to go in terms of we can get that state running. Running that state won't do anything actually useful because we've only just added it to the project there. So you know, we actually need to start setting up the code for that. So state main.h. Let's have a look if everything's okay. Include Penjin states. It's inheriting the base state. It's not doing anything useful. So as it is a game state, we're going to need virtual void render, virtual void update, virtual void user input. Okay, you do have an init function as well, which we may or may not need. Let's see how we go. So that's virtual void init. Okay, just if you want to double check with the state title there, let's see. Yeah, that's basically what we had for the state title as well. So back to state main. What will we need? Well, we're making a Pong game. So, yeah, you need to think, what would you need in a Pong game? You're going to need 2 bats and a ball. So, let's forward declare a ball here. So class ball. class bat, just to keep it short words. Right. Okay. Forward declared them, so we can use them as so. We can go ball pointer ball. We can do bat pointer bats. Yes, plural, because we'll dynamically allocate 2 bats once we actually get into the proper setup here, but we're just preparing the objects. Right, so we've created these objects. We haven't set up the classes for them yet, so let's go do that. So again, we go to the new file, new class, class name ball, inherits another class. Yeah, we will inherit sprite. Why are we inheriting sprite? We're inheriting sprite because we're going to be loading a sprite image. So from a PNG, nice image format for sprites, has lossless compression, so it works out nice for what we want to do. Add that to the example folder here, open that, and create. Sorry that the VirtualBox menu keeps popping up there. Add it to the current project, and we've got the ball object here. It's got a sprite which has a position, so what do we need for a ball? Well, the ball will need a velocity, so you can do vector 2df velocity. Okay, what else would the ball need? Well, let's have a think. It will need a render function, but it is inheriting sprite, so sprite will have a render function for it, so we don't need to do that as such. We will need a function to collide with the ceiling and the floor walls, so let's do that. Void invert y. We'll also need a function that will invert the velocity when it hits the paddles, so void invert x. Righto. What else? Well, I think that is almost it. We'll need an update function to constantly update its position as well, so that would be void update. Right. Okay, so we can go on to the CPP of the ball there now. Now we've had a little think about that, and the velocity will start. Well, let's go velocity. I can spell velocity dot x equals velocity dot y equals 1. We're just going to make it scroll to the right and downwards diagonally, just for example's sake, really. So that's that set up. We can do the invert function, so void ball invert x, and we will do velocity dot velocity. Why is that not doing the autocomplete? Anyway, invert x dot x equals negative velocity dot x. Void ball invert y, and again it's a simple velocity dot y equals the negative velocity dot y. Okay, What else? Let's have a look. We need the update function. That's what I'm forgetting. So void ball update, and that's simply we add the velocity to the sprite's position. So how will we do that? We'll do vector 2df pos equals get position. Why is that not coming up? Let's do this, get position, see if that helps. Nope, it's being awkward. There we go. No, it's not getting the right information. I believe using the sprite anyway, we can do get position. Then we will update that position with the velocity. So pos equals pos plus velocity. And then simply set that position back. So set position pos. I've done it like that mainly just to show you clearly what's going on there. You probably know this already, but basic velocity stuff. Right, so that should get us a ball bouncing on the screen, but you're probably thinking, well, we've got nothing to display on the screen because we've not loaded any images. You're right, so we need to create a simple ball image. Again, I'll not show you the full process, but if you go to your update, no, we don't go to the update manager, sorry. If you go to Synaptic, there you go. Type in Penjin as your password. You know the score by now. We have a very nice image program in Linux called GIMP. I've already installed it as usual. As you can see, there's lots of localization files there if needed. So if you click that to install, press apply, you'll have to wait until it installs. But in any case, cancel. We will save all though. In any case, install that. If you see I've already ran it, you can type GIMP in the search box there. Run the GIMP. Let's bring out the GIMP. But the GIMP's sleeping. Well, you better wake him up now. Anybody that's seen Reservoir Dogs know what I'm talking about. Anybody else, you probably think I'm mad, which is a bit true. Anyway, as you can see, we've got that. So we create a new file. We don't want it that big. We want something simple like 32 by 32, and we'll create a simple ball image there. Okay, make it full screen and we can see what I did. In Penjin, well, in SDL really, because that's the image, the rendering engine that we're working with currently. With sprites, it's better to have a color key, as it's faster. You can do full alpha, but full alpha done in software like SDL it can be quite slow if you overdo it. So what we'll do is we'll simply do a fill of magenta. I've already set it up here. We'll do a fill of magenta, and that will be our keyed color. So magenta, if you didn't know, is 255 of red and 255 of blue. So there you go. I've already set it up. Or if you want HTML there, FF00FF. So hit OK, fill that in magenta. Then we want to do that's the zoom. Where's shapes in the GIMP? I forget. Scale, blend tool, perspective tool. Yep, I've really forgot where the shapes are. Select by colour. Yeah, I can see everything but not a simple shape. So we'll do it with the pencil anyway. We'll just make a big circle. Mode, dissolve, colour arrays, multiply, opacity full, brush. Big circle. Okay, brush dynamics. Pressure. Fade out, apply jitter. This would be a lot easier if I could just set a circle, but in any case, it's not looking like that. So, just a blue circle, make it a bit bigger. I said bigger, so that. Just want it to be touching the edge. Oh, now I made it too big again. Slide box is working too quickly. 5. Too big. Okay. 2. Too big. 1.5. Sorry about this, we will get there eventually. Aha! 1.5. That seems almost right. Let's make it a touch bigger. Touch bigger. Come on. This is bugging me now. I made it too big. Oh, man. Okay, that looks like the best we're going to do. So just click that there. We've got a nice blue circle. So we want to hit File up here. We want to save as. Find your Penjin project folder. So it's in Documents, Programming, Penjin, Example. And we haven't got a built folder there. So let's do that. Create folder. I don't know, call it working directory, call it built, whatever, just remember what you've called it. I'll call it built. Seems to be the Penjin one convention. And we'll call that ball.png. Save it as a PNG. Although I think it does do it by extension. And with that, hit save. Yep, okay. Make sure your compression level is maximum. There you go. So just minimize that for now, because we will need to do a bit more work with the GIMP later. So we got a ball image. We should load the ball image. So this is a sprite. So load sprite there. And it is ball. Well, we'll probably put it in images. Ball.png. I know we didn't put it there. I know I'm probably making this more confusing than it needs to be, but you should organize your resources. It's not very good to just keep them in one big directory, so we will go back and do that. So if we open that file, the folder there. Yeah, we've got this built folder, we've got ball.png, create another folder there, call that images, move the ball into there. Simple. Right, so that should be able to find that. Apart from one thing I remember that we didn't set up properly from the last video. So if you go to properties, go to build targets, you can see execution working directory is just set as dot. You don't want it as dot, you want it as built, because that's where it's going to look for your images, etc. So change that there for debug, change that there for release to built, hit OK, save all. Right, so now if we run that, it can see that. But we've set up a ball. We need to display it actually in the state main state. So go to your state main.cpp. In your constructor there, you can do ball equals null, ball equals new ball. In the destructor, you can delete the ball, and you can set ball to null, mainly to get you into the habit of setting your pointers to null after you delete them, because in all honesty, when it calls this destructor here and exits out, you don't need these pointers anymore. It's just mainly to get you into the habit there of being tidy with your memory management. Right, to use the ball here, we're going to have to include it. So hash include ball dot h. Okay. What else? Well, to use the sprite, again, this is something unfortunately you have to get used to with Penjin 1. I've explained this on the forums, but it is cobbled together from my uni days. It is just useful code taped together. A lot of it is rushed. A lot of it is built from inexperience, which I've tried to improve. But at the end of the day, this is why I decided to work on Penjin 2, which is a start from scratch, because it's useful code, but it is built from experience. That's the best way I can put it. So you have to put up with a few nuances here and there, but it is a nice cross-platform game engine in many respects, not all respects. But anyway, what I'm getting down to is we need to add the sprite class to the Penjin base directory now. So if you add files, we're in the Penjin base folder there, and if you look for sprite, there's a sprite CPP and there's a sprite H. Add them to all targets, and then it knows what a sprite is. Right, I'm sorry to go off on all these tangents. I hope you can bear with me. Let's carry on. So in the state main init function, we need to create that void state main init. This is where you will actually load your sprite for the ball. So ball, or back, ball, arrow, load. Sorry, I'm having a, as they call, a blonde moment. No offense meant to blondes there. We've already loaded the sprite within the class, so we don't need to do that. We probably don't need an init function. We need a render function though, that we do need. So void state main render, and just do ball arrow render. Okay, and the update function void state main update ball update. Okay, we also need a user input function to handle input handling, obviously. So state main user input. Right, do input pointer update. We will need to check for the cross button being pressed in this state. So if you do if input is quit, you then nullify the state. This will allow the game to exit gracefully. Anything else we need to check? Well, we will need Pong controls there, but let's see how we're going so far. Okay, I appear to have lost my mouse. This is troubling. Please bear with me. There we go. Okay, so save everything and we will run that in debug mode. Hopefully this will work. As you can see, this has popped up and showing you the compilation messages. Alright, what went wrong? Get position was not declared in this scope. It's because I didn't write get position, I wrote get position, which doesn't mean anything. Let's try that. Save, run. There you go. Okay, so we have a ball. It is running in 60 frames per second. I think the video capture's slowing that down. And at the moment, it just goes right off the screen. We do no display clearing, so it leaves a trail. So let's close that, which should exit correctly, as it has done. What you want to do in your main state is, before you render the ball, clear the screen. How do you clear the screen? You do graphics, I think it's dot, yeah, graphics dot, no it's not, it's a namespace, so graphics clear screen. And let's save that and run again. There you go. Again, apologies about the performance. I think that's with the video capture running again. It is running a cool 60 frames per second. So that's that. We want to do the invert when it goes off the edge of the screen there. Just for now, to wrap up this tutorial part, let's do this in the ball. What we will do is we will check here. So let's have that as calc velocity. Missing an O, there you go. And we'll have this part here as check collisions. So what collision do we need to check? We actually need to check the position if it goes off the top or the bottom of the screen. So if we do if pause dot go on, we're checking top and the bottom, so pause dot y is less than 0, or there you go, or if pos.y is greater than, what will it be greater than? It'll be greater than the screen height, and the screen height you can get with graphics : get, where are we? Get y resolution, because we're talking height, aren't we? So if that happens, what will you do? You will invert the y. Invert y. Righto. For now, we will add the bats in the next tutorial, I think, because I don't want to make the video too long, and overdo it with your attention span. I don't know how good your attention span might be over there. So if POSX is less than 0, or POSX is greater than graphics : get X resolution, then we invert X. Right, now hopefully we might have some bugging out, but hopefully we have the ball bouncing around the screen when we compile this now, when we build and run. So there goes the ball again, a bit juddery because of the video capture, and there you go, it's rebounded off the wall, and it does rebound. We haven't taken into account the ball's width, which we can add that what do you call it, that I suck at words. We can add that adjustment later, but there you go, that's basically how to handle a sprite in Penjin. We've got a nice bouncy ball on the screen. Thank you for watching. Please keep watching. Please rate, comment, subscribe, give me feedback how to improve these video tutorials and what direction you want to take with the tutorials, and have a great day. Thank you. Bye.